Welcome to Module 1 on Python data structures, focusing on lists. In this module, we will explore one of the most commonly used data structures in Python. Lists allow us to store multiple values in a single variable, making our programs more efficient and organized. In Python, a list is an ordered, mutable, and flexible collection of items. This means we can store different types of data, change values, and manage data easily. Lists are created using square brackets, and each element is separated by commas. A list is a collection of items arranged in a particular order. Each item is separated by commas and enclosed within square brackets. For example, a list can store strings, numbers, or even mixed data types in one structure. Let's look at this code. We define two lists. List_1 contains strings, apple, orange, grape, and banana. List_2 contains mixed data types, an integer 78, a string Lisa, a float 5.1, and another string car. Next, we use print, list_1, and print, list_2. Python prints the entire list exactly as stored, including square brackets and commas. That's why the output shows, first line, all elements of list_1, second line, all elements of list_2. Lists are ordered and mutable, meaning their elements can be changed after creation. Each value in a list is called an item. Unlike arrays in some programming languages, Python lists can store different data types such as integers, strings, floats, and Boolean values. To access elements in a list, we use indexing. The first element starts at index 0. Python also supports negative indexing, where -1 refers to the last item in the list. Here, we access elements using indexing. For example, list_1, 0, returns apple because indexing starts at 0. List_1, 1, returns orange for negative indexing. List_1, -1, returns banana, which is the last item. List_1, -2, returns grape. Python counts backward when using negative indices. Indexing allows us to retrieve specific elements from a list. Positive indexing starts from 0, while negative indexing starts from the end of the list. This makes accessing elements flexible and efficient. In this example, we see how each item in the list corresponds to a specific index. Using these indices, we can easily access or manipulate elements within the list. Let's analyze the code step by step. First, we define list_1 equals apple, orange, grape, banana, then print list_1 prints the whole list. Print list_1, 1 prints the second element, which is orange. Print list_1, -1 prints the last element, which is banana. So the output appears as full list, then orange, then banana. Here, we access elements using both positive and negative indices. We can also use list elements within expressions, such as converting a value to uppercase or calculating lengths. In this example, we use a list inside a formatted string. List_1, 2, refers to grape, then upper, converts it to grape, so the message becomes, she loves to eat grape. Finally, len, message, counts the number of characters in the string, which is 4 for the list length example shown. Lists are mutable, meaning we can change their values. To modify an element, we simply use its index and assign a new value. This allows dynamic updates to our data. Here, we modify a list element. Initially, list_1 equals apple, orange, grape, banana, then list_1, 2, equals rambutan. This replaces the element at index 2, which is grape, with rambutan. So the updated list becomes apple, orange, rambutan, banana. To add a new item to a list, we use the append method. This adds the element to the end of the list, making it simple to grow our data collection. In this code, list_1.append, rambutan, the append function adds the new item to the end of the list. So the original list, apple, orange, grape, banana becomes apple, orange, grape, banana, rambutan. If we want to add an element at a specific position, we use the insert method. We specify the index and the value, and the list updates accordingly. Here we use cars.insert to Volkswagen. This means insert the value at index 2. Original list, Proton, Honda, Toyota, BMW. After insertion, Proton, Honda, Volkswagen, Toyota, BMW. Notice the existing elements shift to the right. We can remove elements using the del statement by specifying the index. This permanently deletes the item from the list. In this slide, we remove an element using del. Correct usage should be del cars 2. This removes the element at index 2, which is Toyota. So the list becomes Proton, Honda, BMW. The pop method removes an item and also returns it. This is useful when we need to use the remove value later in the program. Here, pop_cars equals cars.pop. Pop removes the last element, which is BMW. Now, cars becomes Proton, Honda, Toyota. Pop_cars stores BMW, so we can still use the remove value. The remove method deletes an item by value instead of index. It removes the first occurrence of the specified value in the list. In this example, cars.remove, Honda, this removes the element by value, not index. So Python searches for Honda and deletes it. The list becomes Proton, Toyota, BMW. The sort method arranges elements in ascending order permanently. Once sorted, the original order cannot be restored unless stored separately. Here, cars.sort, this sorts the list alphabetically in ascending order. Original, Proton, Honda, Toyota, BMW, Audi. Sorted result, Audi, BMW, Honda, Proton, Toyota. The original order is permanently changed. The sorted function allows us to sort a list temporarily. This means the original list remains unchanged, giving us flexibility in data handling. In this case, sorted cars creates a new sorted list, but the original list remains unchanged. So, first print shows original list, second print shows sorted list, third print confirms original list is still the same. The reverse method flips the order of elements in a list. This is useful when we want to process data in the opposite sequence. Here, cars.reverse, this reverses the order of the list. So, Proton, Honda, Toyota, BMW, Audi becomes Audi, BMW, Toyota, Honda, Proton. To find a number of elements in a list, we use the len function. This helps us understand the size of our data collection. Len, cars, returns the number of elements in the list. In this example, there are 4 items, so the output is 4. When working with numerical lists, we can use functions like min, max, and sum to perform quick calculations and analysis. Given digits equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, min, returns the smallest value 0, max, returns the largest value 9, sum, adds all numbers 45. Slicing allows us to extract a portion of a list using a range of indices. The format is start to end, where the end index is not included. Here we use slicing, pets, 1:3, start at index 1 rabbit stop before index 3 so include dot result, rabbit, dot the end index is always excluded. We can slice lists in different ways, including using negative indices or omitting start and end values to retrieve specific sections of data. For pets, -2 this starts from the second last element and goes to the end. So the result is hamster, snake. To copy a list, we use slicing with a colon. This creates a new independent list, ensuring changes do not affect the original. In this example, copying a list allows two separate lists to exist independently. Changes in one list do not affect the other. Here, friend_foods equals my_foods, smiley face. This creates a copy. So when cannoli is added to my_foods, ice cream is added to friend_foods, both lists are different and independent. Assigning one list to another does not create a copy. Instead, both variables refer to the same list. Any changes will affect both variables. Here, friend_foods equals my_foods. This does not create a copy. Both variables refer to the same list. So when we append items, both lists show the same updated values. Stride in slicing determines the step size. It controls how many elements to skip when retrieving items from a list. These examples demonstrate how stride can be used to skip elements or reverse a list efficiently. For numbers, 1:11:2, start at index 1, stop before 11, step by 2 so we skip every other element, result, 1, 3, 5, 7, 9, 4, numbers, ::-1, this reverses the list by stepping backward. In summary, Python provides many built-in functions for lists, such as append, insert, remove, pop, sort, reverse, and more. These functions make lists powerful and flexible for handling data.